Welcome. So in this session, we are going to introduce the concept of system of two variables and two unknowns. So I'll first state the number of solutions that any given linear system of equations can have, and then solve or state the methods of solving system of two equations in two variables. Thereafter, in the next session, we'll be doing some examples to illustrate how each method works. So theorem. So this theorem is about the number of solutions of a system of linear equation. This works for any system of linear equations, not just for two variables or two equations alone. So for any linear equation, system of linear equations, in n variables, precisely one of the following is true. So one, the system has exactly one solution. Now, when the system has a system that has a solution is called consistent. So this is consistent system. Number two, the system has an infinite number of solutions. So this is still a consistent system. And lastly, the system has no solution. And a solution that has no solution is called inconsistent. So I can illustrate these possibilities using a system of two linear equations. Because mostly that's what we are going to be measuring on in this course. So a solution of the system A1x1 plus A2x2 equals to B1 A2x2 x1 plus A this say A21 A22 x2 equals to B2 is any ordered pair x1, x2 that satisfies both the equation. And then as a system, so actually these are called, this canonical system of two linear equations in two unknowns. This is what we call simultaneous equations. A system of linear equations actually can be linear equations or just any other equations, is said to be consistent if it has at least one solution. Otherwise, it is inconsistent. So inconsistent means no solution. Now we can illustrate the concept of a system having one solution, exactly one solution, infinitely many solutions, or no solution by using a set of equations in two unknowns. So the system, that's one, x plus y equals to 3, x minus y equals to -1, has exactly one solution where x is given by 1 and y is given by 2. As can be illustrated by the graph. So these are, remember, these are just lines. So x plus y equals to 3, the same as the line y equals to minus x plus 3. And these are only the same as line y equals to x plus 1. So if you draw, this is how the graph so we have this, and then we have this. So -1, so remember we have the lines x plus y equals to 3, and then x minus y equals to -1. So from this is the equation, y equals to minus x plus 3. So this is the graph x plus y equals to 3, and this is x minus y equals to -1. So of course, this one will be given by y equals to x plus 1. So when you solve these two equations, you get x equals to 1 and y equals to 2. So this is a point of intersection, 1, 2. So putting 1 in this equation, 1 minus 2 is -1, and then 1 plus 2 is 3. So this is an example of a system of two equations having exactly one solution. Now, the system x plus y equals to 3 and 2x plus 2y equals to 6 has an infinite number of solutions. Because the second equation is a result of multiplying both sides of equation 1 so this is what you're calling equation 1, this is what you're calling equation 2, by 2. So then, if you are to draw those two equations, these are actually the same line. So we'll have this case. So this is the equation x plus y given by 3. So this is 3, this is also 3. And when you draw the line 2x plus 2y plus 6 equals to 6 will be actually along the same line. So the parametric solution is simply x equals to 3 minus t and y equals to t, where t is any real number. So there are infinitely many solutions for that given case. So just one line, and see the system x plus y equals to 3, x plus y equals to 1 has no solution because it is impossible for the sum of two numbers to be 3 and 1 at the same time. So if we draw the graphs of these two equations, are two parallel lines. This is our y-axis, this is our x-axis. So this line and this line. So this is the line x plus y equals to 3. This x plus y equals to 1. So this 1, 1, 3, 3. So these are parallel lines. No solution. And this is an example of an inconsistent system. So majorly, those are the 3 different scenarios. For a system of linear equations, we can have it having exactly 1 solution, or infinitely many solutions, or no solutions, no solution at all. So let's take methods of solving simultaneous equations, and then the next session will be introducing how each method works. So methods of solving simultaneous linear equations in 2 unknowns. So the first method is what we call graphical method. Not really, say start by substitution method. Next, we have elimination method. Number 3, we have graphical method. And number 4, we have what we call matrix method. So the next session will illustrate how substitution method works, the elimination method works. Thank you.